Hello friends, welcome to TECHQUEST channel. This is for the medical technologists by Your Tech. In today's video, we will see the commonly used biochemical reagents, the standard calibrators, and the quality control materials. Standard solutions containing single analyte with known concentration. Standard reagents are used for comparison and determine the unknown concentration present in the patient sample. A standard curve is made for each analyte. From the curve, the unknown patient sample concentration is detected. Standard solutions contain only one analyte and they are dissolved in solvent, usually the distilled water. A stock standard solution is made with higher concentration and the standard graph is made to detect the instrument response to each concentrations. For example, 1000 milligrams per deciliter glucose is made as stock solution by dissolving 1000 milligrams of glucose in 100 ml of distilled water. A working standard is made from stock standard by diluting the stock standard for 100 milligrams in 100 ml. This working standard is used as a quality control material for each day or each shift or each batch of samples. If the working standard is within the 2 SD range, the patient results are reported. The stock standard can be refrigerated with preservative for long time. Standard graphs may not accurately represent the real world behavior of an analyte in the complex sample matrix. Standard graphs can be sensitive to variations in instrument performance and environmental conditions. Disadvantages of the standard solutions. Interfering substances in blood test can cause inaccurate results by affecting how the tests are performed or how the results are interpreted. There are two types of substances, endogenous, normally present in the sample hemolysis, lipemic samples, bilirubin and protein present in the sample. Autoantibodies or heterophil antibodies can bind to reagents and cause false results. Exogenous substances like drugs, metabolites, biotin, anticoagulant, and intravenous fluids can also interfere in test results. The interfering substances can alter the test results. The standard solution contains pure analyte in distilled water, so the calibrators are used to mimic like a patient sample. Calibrators or the reference materials provide a more accurate and reliable way to establish a relationship between instrument response and the concentration or the value of analyte. They account for matrix effect and often better control over measurement uncertainty leads to more precise and accurate results compared to the standard solutions. Calibrators are prepared in a similar matrix to the samples that affect instrument response and minimize the major source of errors. Calibrators are traceable to known standard having high level of accuracy and comparability of results across different labs and different instruments. Calibrators provide a more accurate and reliable way to establish the relationship between instrument response and analyte concentration, especially when dealing with complex samples. Calibrators contain matrix material and mimic like a patient sample. More than one analyte can be added and same calibrator can be used for many analytes. Standard graphs are useful for initial assessment and establishing basic relationship. Calibrators gives a more advanced and reliable approach for accurate and precise measurements in various analytical and measurement applications. Calibrators are more expensive compared to standard solutions. The quality control materials. Specimens are solutions used for quality control purpose. These are containing multi-analytes with known volumes. Quality control materials are used to check the calibration and the quality of instrument. Controls are substances that contain a known amount of analyte being tested. Controls are tested at the same time and in the same way as patient sample. The purpose of the control is to validate the reliability of the test system and evaluate the operator's performance and environmental conditions that might impact results. Controls must be appropriate for the targeted diagnostic test. The analyte should be present in the measurable form. The amount of the analyte present in the control should be close to the medical decisions points of the test. Means the control should check both low values and high values. Controls should have the same matrix as the patient sample. Controls may be frozen, freeze-dried or chemically preserved. Control materials may be purchased, obtained from a central or reference lab or made in-house by pooling sera from different samples. Controls are available in high, normal and low ranges. For same assay, it is important to include controls with value near the low end of detection. The standard and calibrators are used for calibration of an analyte in an instrument. The difference is the matrix present between them. Standard calibrators and the control materials can be used as quality control to check the calibration and the instrument status. All three of them have known amount of analyte in solutions. The standard and the calibrators also can be used as a QC material. The stock standard solution can be used for standard curve, the linearity, and the same stock solution is used as calibration with required dilutions. The working standard solution can be used as a quality control material. The calibrators are used for calibrating the analyte with instrument and the methodology. The same calibrators can be used as a quality control material also. The quality control materials can only be used as control material for checking the calibration, instrument status and the procedure accuracy. All three materials have the known amount of analytes. They can be used for quality control purpose. Thank you. Thanks for watching. Like, share and subscribe this channel. Thank you.